Welcome back to our weekly video series Spark, where we highlight new features based on customer requests. This week, we are going to introduce the Spatial Correlations feature in INTERCONNECT. When performing Monte Carlo simulations in INTERCONNECT, it is now possible to add spatial correlations between the statistical properties of the elements in the circuit. For example, in this circuit with two ring modulators, the nominal resonance peaks of the two rings are located at the same wavelength. However, if statistical variations in the ring and waveguide properties are included, there will be a difference in the locations of the resonance peaks. We can determine the statistical distribution of these differences using the Monte Carlo analysis tool in INTERCONNECT. With no spatial correlations between the element properties, the resonance peaks vary over a range of around 6 nanometers. If spatial correlations are included, the variation in the peak differences is reduced. If the distance between the rings is increased from 200 microns to 500 microns, the variation in the peak difference increases. Before running their Monte Carlo analysis, users can enable or disable the spatial correlations, as well as visualize the positions of the elements in a given spatial correlation group. This plot displays the distances between the selected element and the other elements in the group. Other elements can be selected with the mouse. This tool can also be used to view the correlation coefficients between pairs of correlated properties. Our Foundry partners are already excited about this new feature. Here is a quote from K.S. Eng, the COO of Compound Tech. Ansys Numerical's new support of spatial correlation effects modeling enables us to deliver a compact model library to our customers that supports accurate yield analysis of their photonic circuits in INTERCONNECT. That's all for this week. Thanks for watching. Stay tuned for a video next week, and don't forget to post your feature requests and ideas in the IX.